Okay, so this lecture is on section 5.3, 5.5, and 5.6. 5.4, in my opinion, also has been put in the wrong place in the book. So we'll come and grab 5.4 near the end. It's important, but it doesn't belong where it is, in my opinion. And I'm not doing it that way. So it's 5.3, and 5.5, and 5.6. We're learning all of those today. And you do not have to follow in your book. You need to follow me, because I'm going to present it different than the way the book does. Okay? So you need to follow me and take any notes that you think are appropriate. Yesterday, if we had something like this, this is just a sample diagram. They're not all like this. But if you have something like this, you're trying to prove that those two triangles are equal, and you were working on yesterday's assignment, you would have to prove that, for example, angle A equals angle D. That's one. You'd have to prove that B equals E. That's two. Maybe they would just hand it to you. Maybe it was given. You'd have to prove that these two angles were equal, which isn't very hard. I hope you understand by now. That would be the third angle. You would have to prove that BC is equal to CE, and that DC is equal to CA, and that BA is equal to DE. That's to get all 6 parts. Turns out that if you think about things a little better, you really only need 3 parts. 3 of the 6, but only certain patterns work. So I guess what I'm trying to tell you is this. Think about this. Forget about this now for a minute. I want you to concentrate on this diagram right here. No. Sorry. If I were to give you all, and I measured them all absolutely perfectly, no problems, and I said, here is a stick this long, here is a stick this long, and here's a stick this long. Now, all of you go and attach them right at the very, very ends. I mean, there's no overlap or nothing like that. Go attach them and make a triangle out of it and bring it back to me. Now you can't actually do that, but pretend that you did. Do you think that if we were able to rotate, turn, reflect, whatever, and put them in a stack, do you think that they would all stack up perfectly? Do you think they would all be exactly the same size and shape? They would have to be, wouldn't they? They're all, if I gave you all the same 3 sets of sticks that were this long. In other words, if I made a triangle out of this like this, and I said this was equal to this, and this was equal to this, and this one here was equal to this one, and I made that triangle out of those 3 sticks like that, and you made your triangle out of those 3 sticks that were exactly the same length, do you think you would all return a triangle that looks exactly like this, so that if we stack them up, you couldn't tell the difference? Okay, then what we've discovered here by doing that little thought experiment is that if everybody will return the exact same triangle, then I don't need all 6 parts. I only need these 3 to prove that this triangle is congruent to your triangle. I don't need all 6. So we call that side, side, side for obvious reasons. So what I'm saying on this is, if for some reason on this diagram over here, I was able to, either it was given to me or you were able to show it for some reason or another. For example, I might say that C bisects BE and AD. If that were the case, then you could say definition of bisector tells me this equals this and this equals this. And perhaps in the given, they already told me that AB equals DE and C is a bisector. So you could get the other side. If you got a picture like this and you did your proof and you got your given, which was AB equals DE, and then in number 2, you defined bisector and got that BC equals CE, and also in the same step, AC equals CD. Then in the third step, you could say triangle ABC is equal to triangle, I put this in, triangle, let's see, ABC, that would be, the ones that would go with it as 1, 3, 1, that would be DEC. You could say that. You could say that they were equal. And the reason would be side, side, side. And that's all you write. Because this triangle sides match up with this triangle sides, and you got all 3 parts, you'd have 2 of them here. Let me go ahead and finish this proof. If I said that AB equals DE, and that's a fact. So I got this equals this. That's one of them. And then I also said C bisects AD and BE. I have to go around that. I'm kind of jumping the gun on this, but I'm just showing you how a proof might shape up that use side, side, side. So I've got one of them right there. I got to define this to get the other two. In other words, I would say that BC is equal to CE and also AC equals CD. So this and this are equal because they got cut in half by the C. And A, you know what? I better not say bisect. I better say midpoint. Sorry, that was my fault. I can also say that AC equals CD because they got cut in half because C is the midpoint of both of those segments. That's why I'm able to say this, and this would be the definition of midpoint. Because if you got a midpoint, it means the two halves are equal. And I've stated both halves of both of these segments. So now I've got 1, 2, 3 sides pairs. That makes them congruent side, side, side. You kind of see how this is going to shape up? Okay, I'm not going to do a proof for every one of these. What I want to know now is, think about this. This is another thought experiment. What if I gave you a stick this long and a stick this long, and I said, the angle that you make with those two sticks has got to be this big. So you go wherever it is you're going to glue things together. One stick on here and one stick on here. So it's exactly that angle that I gave you. And it would look something like this. I have a stick coming down like this, maybe this one. And another one coming out like this, so that this angle and this angle are the same. So this equals this. And this equals this. And this angle equals this one. So these are the three things that I gave you to build it with. You don't have the third stick, but you find a stick and measure it just perfect so that it joins these two together. Would you all return the same triangle? Would they have to be exactly the same? I mean, would you all have to come up with the same third stick? You would. And by the way, that's called side, angle, side. Now, let me take a little sideline here for just a minute and teach you how to, this was a little bit long, teach you how to read these things, these patterns. Side, side, side is pretty obvious, I think. This one is side, angle, side. Now, pay attention here. If you can get this at the outset, you're going to be a lot better off. You won't be making mistakes. Now, watch. I realize that there are 3 parts right here in this triangle that are marked, and they're equal to the ones I gave you. And there's only 3 as opposed to 6. But if you were going to name this, you cannot do. You can't go side and come around here and grab this side angle. This is not side angle. It is also not angle side. It is side angle side, whether you do it this way or this way. What I'm saying is these are clustered together. Stay with it, and I mean stay with the cluster. Here's how you can tell. If you decide, you look at that and you say, I think that's side angle. If you go around a triangle, you're going to have a side, then an angle, then a side, then an angle, then a side, then an angle, and they're going to alternate all the way around. If you go from here and try to grab this next, you would have to go side, angle, and that's not marked, and that side is not marked. If you ever hit 2 things in a row going around that have no marks, you're going the wrong direction. Side angle side or side angle side. This is not side angle. You can't, this is the desert out here. There's nothing marked. You got an angle and a side and an angle with no marks before you hit something with a side, if you go clockwise or counterclockwise. If you ever hit 2 in a row with no mark, you're going the wrong direction. So this is side angle side, and that's all it can be called. Okay? Side angle side. All right. So if you can get 2 triangles like this one up here that have 2 side pairs and the angle in between them, between the 2 sides made by those 2 sides equal, then you can claim that the triangles are equal, and that would be the reason. So you'd have this kind of a statement on the left and a side angle side on the right if you can establish this pattern. Okay, so let's try another one. What if I gave you a stick this long? That's all you get is that one stick, and the angle on this side has to be this big, and the angle on this side over here has to be this big. So you're going to go find 2 more sticks. And you're going to lay the stick that I gave you down like this. I'm going to lay it down, and I'm going to take the next stick that I got, and it doesn't have to be pretty long at first. And the next stick that I got is going to match that angle. So I'm going to draw it up here like this, and it's a big old long stick like that. But this angle, I lay it down perfectly so that this angle and that one are the same. I come over here on this end of it, because that's where that angle's got to be, and I make that just right like this with a big old long stick so that this equals this. If you cut those two sticks off where they meet, the new sticks that you got, will you always get the same triangle? Do you think? Think you will? So you all got this length stick, and you got to find two others. You got to make them come out of that stick exactly the angles I prescribed. They will all cross at the same point. That's called, believe it or not, angle, side, angle. Again, if you are going to try to name this and you run into too many things that are not marked, for example, if you want to go around this way, starting with this one, you would go angle, blank, blank, oh, wrong direction, angle, side, angle. And it is only angle, side, angle. I don't care which one of these you start with. It's angle, side, angle, or angle, side, angle. But it is not angle, angle, side. Too much of a desert in between the two angles if you do that. This is angle, side, angle. They cluster together, stay with them. And that also is a reason. So if you can get two triangles in a situation like this, where you have two pairs of angles and the included side, we say the one that connects them, and the included side, then you can say they are equal by angle, side, angle. So it appears that what we're talking about is 3 letters at a time that seem to be made up of S's and A's. So can you help me figure out the other combinations that we haven't considered yet, so that we make sure we consider them all? You think of another one that we might have that involve A's and S's in 3s in another combination? Angle, angle, angle. We're going to consider that one. What else? Angle, angle, side, she's saying. Are you okay? And by the way, angle, angle, side, and side, angle, angle are the same, whether you read it forwards or backwards. What else? Angle, side, side. And that looks terrible. I'm going to leave it up there. Can you think of any other A and S combinations that we have not written?
SSA, side angle.
Side angle is the backwards of this one. And the backwards of this one is side angle, angle. And I'll take it either way. It doesn't matter which way you read it, but it's the same thing.
Don't you have them all?
I think we do. I think we have them all. And we've already decided that these 3 are okay, right? So now that we've decided, I mean, we got these S's and A's coming in 3s, and we've already established these by just throwing them up there. I thought maybe we had to consider all the others and see, and make sure we've got them all, and then consider each one and see which ones seem to work. So if I give you this angle and this angle and this angle, and that's all you get are the angles, and I tell you to go find some sticks and arrange them so that these 3 angles are copied, maybe I ought to make them slightly different. I don't want you to think they're all the same. If those are the 3 angles in a triangle, and I ask you to go find some sticks and make sure those angles work, will you all bring me the same triangle? If I take a stick and lay it down here, a big old long stick, and make sure that the next stick has that angle right there, like this. And then whatever stick this is, I just go out a ways and I say, okay, I'm gonna make that one be that tiny. Will this one have to be the size of this one?
Yes.
It will, if I've given you angles that have to 180. So these will be all equal, and you cut these off so you make a triangle. Will you all return this triangle? I don't think so. Because I might choose sticks this big. And have the same angles. Now keep in mind, I'm freehanding this, so it's probably not going to come out the same. But if I use those 3 angles and I made sure I got those 3 angles there, but if I use sticks this long, I could still have these same 3 angles, and you might bring one back like this with those same 3 angles, and they would be the same shape. There's nothing to guarantee they're the same size.
So that one doesn't work then?
It does not work. And so if you get an angle, you got nothing for congruence. Now, we're going to study something later called similarity. It means it has the same shape, but maybe a different size. That'll work great there. But we're not doing that. We're doing congruent. And the word congruent means same size and shape. This will guarantee the same shape, but not the same size. And so that one's out.
So angles will never be congruent.
We'll never prove congruence with angle, not congruence. And we'll come back to it later when we do what's called similarity. But for congruence, this one is out. Okay, so consider this one now. Angle, side, and it's got to be in a certain pattern. Angle, side. I'm going to give you two angles again. Say this angle, and a side. This long, we'll say, I'll give you that stick, and it's got to have those angles coming off of it, or maybe not coming off of it. This one's a little harder to show. If I take that stick that I gave you, that's this long, and I have that angle coming off of it like this, so that this is equal to this, and these are equal. I don't want to have this one coming off of here because I've already got that one. That's angle, side, angle. I need to have that other angle, this one right here, coming off right here. It's got to be in this order, so that it's angle, and then an angle, and then a side. Now, can I do that? Because obviously I've cut this side that I gave myself off, but there's nothing that says how long this side has to be. So maybe if I made it longer, I'm going to have to get this one out of the way. Maybe if I made that longer and longer in such a way that I could have that angle coming off of it and accommodate that. If I made it just the right length. So I have angle, side. If I made it just the right length so that coming off of here would meet this one down here, do you think you'd all return that same triangle? Can you come up with a triangle that you would tell me what you might? Because again, this side is not fixed. You go grab a stick anywhere you want. You move up along it in such a way that this angle is preserved right here until you go up there long enough so that you get this angle coming off there, and it just exactly joins this down here. If I go up far enough to keep that angle, come down there. This is a harder one to demonstrate. Whether you buy it or not, it's a good one. We'll keep it. So we've got this one, this one, this one, and this one. This is actually a reasonable one to use. It's kind of a weird one. But look at this. It is angle, side, or side, angle, and I don't care which one you write, but it is not angle, side, angle. Because if you do that, you've got too much not marked as you go around. This is not angle, side, angle. This is angle, side, or side, angle. Do you understand what I'm saying? This one's a difficult one. You can't start here and go angle. That would be okay because there's only one gap. Angle, gap, angle. And then you run into two before you get set. So it's not angle. Well, it is angle, side, but not by going around this way. It's angle, side, or side, angle. Got to hang together. They got to be close together before you name the pattern. Are you with me? This one's just a weird one, but it works. You got to name it, give it the right name. Either angle, side, or side, angle, depending on how you see it. But it's got to go right here. You can't come around this way to grab anything because there's too many empty spots. Okay, the last one to consider is angle, side, side. When we actually write this and talk about it, we will call it side, side, angle. I don't care. I'm not offended. I mean, this is all through the Bible. Just saying, it's not that bad of a word. Anyway, so consider this. Angle, side, side would be if I gave you this side, a side this long, and a side this long, and an angle, one angle. But you've got to put it together in that pattern. So here's my angle. I'll draw my angle first. And I got to have this angle. That's prescribed. And I'm going to extend this stick out a little ways. Let's see. Let's let this one be this one. This one right here. I'm going to make it be this one. This one. I can't make this one be this one because then I would have side, angle, side, which we've already agreed is good. So if it's going to be angle, side, side, then this one right here has got to come down here. Like that. That's angle, side, side. So my question is, if I gave you all two sticks this long and an angle that has to come, the one of them has to be with third side you don't know the length of, would you all return the same triangle? You guys are too quick to agree. You would not return the same triangle every single time. Because watch, this is tricky. Very tricky, so watch. Do you guys remember in elementary school about a year when you guys would make skeletons? You'd cut some things out and you'd make them move by putting on the joints, your elbows and your knees and your hips and stuff, those little brad thingies. You'd stick it through there and then open the flange up in the back so that it would swing and move. I want you to pretend that there's one of those right here for these two legs right here. So that both of the, if I were to move those things around like this, that angle would change, get bigger or smaller. Here's the thing. Here's what you got to realize. Shh. This side right here, that is not fixed. It doesn't have to be this length. So I could bring this guy right here. I could swing that leg. And if I held this one so that because see, that angle's fixed. You can't mess with that angle. If I were to swing that leg, it might swing like this, and it would swing way over here because it's longer. It would swing way too far. Okay, so I need to make a change here. I can see how this is going to go. Hang on just a minute. Let's pretend, I'm sorry, I screwed this up. It's my mistake. Let's pretend that the angle is over here, this angle. It's going to be important. If that's the angle that I had right there, and it doesn't have to be any particular size, let's make it small enough so that it looks like this one. And I put that stick coming off of here and this little stick coming off of there, and this side is not fixed, and there's still a brad up here. If I swung that, this one can't swing because this angle's fixed. This one could swing, and if I swung it like a compass, like that right there, where this leg is a certain length, you can't do anything about it. Then the end of it, if I swing it in, would follow a path like this. The end of it would until it came up right over there. Do you agree with that? Kind of like making a circle. And it would follow this path right to here until it hit this side again. That's just as long as that. So what I really have here is a possibility of having this triangle that looks like this, and one of having this triangle that looks like this. Still with the same side and the same angle. And those are not congruent. See what I mean? So it is possible under these circumstances to return two different types of triangles. And because of that, we do not accept it because it has to work all the time to be acceptable, to work. It has to work in every circumstance. And this doesn't. Now, whether you buy the argument or not, here's what you got to memorize to be successful. There are 6 possibilities. 4 of them work, and you need to memorize these 4. So I'm going to put this up here with the others. Angle, side, put a circle around it, and I'm going to erase everything else. These are the only 4 that you can prove triangles congruent with only 3 things, and they have to be with only 3 of the 6 things, and they have to be in these patterns, and you have to know how to read the patterns. This is side, angle, or angle, side. It is not side, angle, side. There's too much desert in here. This is not side, angle, side. This is side, angle, and angle, side. This one doesn't work in that pattern. Okay. So angle doesn't work because you could get different size triangles, and angle, side, angle doesn't work because the shape doesn't have to be the same in each case. Okay, believe it or not, you have just had the lecture on 3 sections. Yeah. They give you a section on side, one on side, and one on angle, side, angle, side. So the last 2 are in a section by themselves. Now, you know them all. Please keep in mind that in order to give you exercises to do out of the book, the author has organized them. Take a look at 5.3. All of your 5.3 proofs and everything you talked about in 5.3 is going to be about this one. This is 5.3 and 5.3 only.
Just that one?
What's that?
Just that one?
That's the only one you're going to see in 5.3. So that'll kind of limit your view on things. You're not going to decide where you're headed. It's going to be that. 5.4, it should not be where it is. So jump over to 5.5 and look at the title of that. Section 5.5 says that the title is Proving Triangles Congruent by Side. And so this is section 5.5 only. Then all of your proofs are going to end up being side. And then the last one, which is 5.6, notice the title to that one. Yeah, it says the title of section 5.6 is going to be Proving Triangles Congruent by Angle, Side, Angle, and Angle, Side. So both of these are in the same section called 5.6. And I have given them all to you. Now you might think, okay, give me the assignment, let me run with it. No, we're gonna do some proofs of all different kinds here to show you the types of things you better watch for and the types of patterns that you build based on things you've learned up to this point. Okay? So let's put some proofs together here and see if you can kind of get a feel for how things are going to happen. And the ones that I'm going to put on the board could be any of these four. When you actually do the exercises, whatever section you're on, it'll be focused on that. But I'm going to give you all of them all at once. We're going to do several examples. So consider this picture here. You'll see this kind of a lot in different orientations. And you might be given something like this. D is the midpoint of AC. And you might be given that AB equals BC. Prove that triangle ABD is equal to triangle CBD. Okay, in the given, we have one equals that belongs to two parts, and it's these. So I mark them. You should mark them so you can see where you're headed. You got to be able to see what pattern is developing. Okay, we got one. We need three in one of those patterns up there.
AD equals DC.
Yep. And if you see words, geometric words that are on your foldables, and they need defining with an equation, you should do that next. It's very likely to hand you another pair of things. So just exactly what you said is correct. We'll define that word. D is the midpoint of AC, means that AD equals DC. That is what midpoint means. It's defined as saying this half equals this one if that's a midpoint. So definition, midpoint. And as you develop these equalses, you should mark them. But we've run out of given. We marked that one. They just handed us that one. We used this up to get this one. We only got two, which means, I know, I appreciate it. And I'm glad you got it, which means that the third thing has got to be one of the, if you can see it, you can say it things. Because there's no more givens to hand us any equalities. So the third one's got to come straight from the picture. If you can see it, you can say it. Now, Brock, what do you see?
You could do the BD equals BD.
Yeah. You'll see that a lot, folks, where you get something equal to itself because it belongs to both triangles. And this is, if you can see it, you can say it. So this is a reflex. And so that last one had to come from something I saw in the picture. Now, do you see the pattern we developed by doing this? I've got three things. They're all sides. You can see it on the picture too if you mark it as you go. And so triangle ABD is equal to triangle CBD because of side, side, side. Done. See it?
Yep.
Okay, you ready for another one?
Yep.
Yep. Okay. Next one, you will see this kind of this, by the way, that was called, I call that a back-to-back picture because they share a side. They're shoved up against each other like that. That's a back-to-back. You will also see several diagrams that I call a bow tie diagram with all, and they can do a lot of stuff with that in the given. So a bow tie diagram looks something like this. Okay, generally joined at a point instead of a side. These aren't back-to-back because they only share a point, and sharing a point does nothing for you. You got to share an entire side to use reflexive. Sometimes they share an entire angle, which is kind of cool. You can use reflexive on that too, but that's not the situation we have here. So this bow tie situation here might give you something like this. In the given, AB is parallel to DE, and BE bisects AD. Prove triangle ABC is equal to triangle DEC. Has to be in that order. Now on this one, we got nothing. We didn't get anything handed to us that we can mark as equal. We did get some things handed to us that we can mark. Got the parallels there, right there, but we got no equalses. And don't ever mark your picture unless you've actually said something is equal first. And we have none. You cannot mark anything equal in this picture. Go ahead.
Can you say angle ABC equals CED?
How about I number everything so you can refer to that? That would be best, and you should do this too. Number everything. Okay, tell me what you want to say.
Angle 2 equals angle 6.
Okay, do you all agree that you can say that? Okay, and the reason?
Parallels imply alternate interior.
That's going to happen a lot, and you're exactly right. The alternate interiors are going to show up a lot. It's the most used one of the parallels. Okay, so we've got an equals. We've got 2 equals 6, and for a valid reason, so we're going to mark it. So that's one pair. That's one.
Would angle 1 equal angle 5?
It would on another transversal. Look, that transversal goes that way and also gives us an alternate interior pair, right? So I'm going to put it in the same step. 1 equals angle 5. Okay, there's 2. Yep,
Would 3 and 4 also be vertical angles?
they would. And you can say that they are equal, but it won't get you anywhere because you'll have angle, 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 which is not valid. We have got to come up with a side someplace because we got a pair of angles. And you could say 3 equals 4. Vertical angles are equal. And it wouldn't hurt or help you. Okay, that would not be the end of the proof because you got to have, notice that all of those things up there that are valid have at least one side in them. We've got to have a side to restrict the size of the thing. So, yeah.
It says, in the given, it says BE bisects AD, so then AC equals CD.
Okay, could we also say that BC equals CE?
Yes.
No.
Oh, yeah, that makes sense.
Think about how this sentence is put together. You're going, that's a sentence? Yes, it is. It says BE bisects AD. Who's doing the cutting?
BE.
BE. What's being cut?
AD.
AD. You can only talk about AD being cut in half. That's it. But you were right what you said first. I just wanted to make sure everybody, you can't say the other one. You got to figure out who's doing the cutting and who's getting cut. And the one getting cut is the only one you can talk about. So 3, we would say AC equals CD. And that's because of the definition of bisector. The definition of bisector says whatever's doing the cutting cuts what's being cut right in half and making the 2 halves equal. And so we mark that. We've got 3. If you count over here in your proof, you got 1, 2, 3. Now you check over here in your picture for the pattern. Not there. The order in which you say these things is irrelevant. It's the pattern that's built in the picture. We've got 3 things. We got 2 angles and a side. Question is, which pattern have we got in the picture to prove that these are congruent?
Angle, angle, side.
Let's see. Yep. See how these hover together? Angle, angle, side. You could also say side, angle, angle. I would accept either one, but it's not angle, side, angle because there's too many marks not given right here. You can't go this direction. You have to go that way. Angle, angle, side, or side, angle, angle. Done. See how that went? You seen it, Reagan?
Yeah.
Okay. ABC goes double mark, single mark. Well, if I go this way, angle, angle, side, it goes single, double, double. So you have to go single, double, double, EDC.
So how do you know where to?
Yeah, I screwed that up. No, I didn't. Let's see. Single, double, double, single, double, double, EDC. Should I have said EDC up there instead of DEC?
Probably.
Oh, no. ABC in the way that it's marked right here is double, single, nothing. I got to go double, single, nothing to name it properly. Do you see what I'm saying? I got to get the letters in the right order. And if I've got ABC in my first one, that goes ABC. If I look at the angles, it goes from the double to the single mark to the nothing. This one's got to go from the double to the single mark to the nothing. DEC. So I have it correct. You know what I mean? They got to be in the same order. They got to be corresponding. Okay, so that one's done. Are you good on that one? That one you had absolutely nothing handed to you at the beginning. at the beginning. We got two of them in one step. Now, just to show you that you could have gone another route on this, I want to show you. It's a way to do it and still get it right. I'll erase these two. We'll get them as we go along. We could have said 2 equals 6. Maybe you didn't recognize that 1 equals 5 because your eyes were just dancing on those vertical angles and you figured, I got to have those, man. I could see those. So you said 2 equals 6 because of the parallels. That's these guys right here. You could also say angle 3 equals angle 4. That's a see it, you can say it thing. Vertical angles are equal. That's certainly reasonable. Mark it. And then get the bisector to help you out. AC equals CD. Definition of bisector. Mark it. I already got it marked right there. And then you've got 3 things. 2 angles and a side. We got the 2 angles in 2 different steps because they were different reasons. So this is a 5-stepper. It's okay. Triangle ABC is equal to triangle DEC because of same pattern, but different angles. I mean, it's still angle, angle, side, or side, angle, angle, but it doesn't come around this way. It's these guys. So it took one more step, but it's still just as good. It depends on what you see. You okay with this? See what's going on? Okay. Let's try another one. Maybe one more to give you an idea of the kinds of things you got to come up with. And then I'll turn you loose on it. Now, keep in mind, your exercises aren't all proofs. I'm just trying to get you to be able to do the hardest part. The rest of the exercises are based on these. They'll have you read some patterns. They'll have you write congruent statements with the right letters in the right order and that kind of thing. And maybe do a little bit of algebra. You know, this is 3x minus 2 and this is 2x minus 7. If you believe they're equal, you set them equal to each other or whatever. But it's the proofs that seem to get people. And that's why I'm only demonstrating those. I think the rest of it will make good sense to you. So consider this picture again. These don't always go the same direction. They don't always do exactly the same thing. So it depends on what you're given. So in this one, I'm going to say QS bisects angle PQR. That's one thing I'm going to give you. Also, QS is perpendicular to PR. Prove triangle PQS is equal to triangle RQS. Again, not a single equals in that given anywhere. I'm going to number the angles. Well, we can refer to this as P and R, but that's it. Can you give me like 10 minutes? Okay, I'll call you back in a minute. Goodbye. So take a look at what we got here. What was I going to say? Oh, we got to get our equals out of these kinds of things right here, some way or another. Oh, I was going to number some angles. That's what it was. I'm going to number this angle and this one and this one and this one. We can refer to these as P and R. That would be fine. You should always number your angles so that as you reference them in your proof, I can see them. That's why the diagram's got to be there. One of the reasons. Got no equalses. Can you tell me anything that I could say is equal based on the given information? Sorry?
QS is equal to QS.
Oh, you're not even going to use the given at all. Okay, that's fine. It doesn't matter the order of these things. That didn't come from anywhere in the given, right? Because that's a see it, say it thing, right? What is it? Okay. And so I will put a mark on there so I can see the pattern developing. I only put one mark on though because there's only one side. Okay, so we got that one. That's a see it, you can say it. They are back to back, and that's one of the first things you should notice.
Did you say PQS equals RQS?
PQS equals RQS. I would, yes, and you can say that, but I'm going to call them 1 and 2. It's just a lot easier to reference them and see what's going on, okay? Okay. Angle 1 equals angle 2. That's what he said. PQS, that's an angle, this angle, and RQS, that's an angle, that's 1 and 2. I've numbered them, and it is true that they are equal. Why?
Is QS bisect there?
It's what?
Is QS bisect there?
Yeah, so what are you gonna put over here for a reason?
She's bisect.
Not bisector,
Angle.
definition, angle bisector. It is an angle that's being cut, so it's the definition of angle bisector. And I'm gonna mark that.
Yes, equal SR.
PS equals SR because,
Q bisect.
does it? Does QS bisect PR?
We don't know that yet.
Oh, no.
Yeah, it's only perpendicular to it. And perpendicular does not necessarily cut in half, because you can have a line like this. And that doesn't necessarily cut it in half.
So then we could say angle 3 equals angle 4.
Oh, we can? Oh, you're right, we can. Angle 3 equals angle 4. Why? Not the definition. The definition of perpendicular can only give you right angles. But we have a theorem, if you'll remember, that says if you have perpendiculars, that implies equal right angles. Remember that one? That one you can say. If you have perpendiculars, it means that we have equal angles and also right angles. We get two things for one. This is what we call a strong theorem. But if you put definition of perpendicular here, you'll be wrong. Because the definition of perpendicular, that thing right there, using its definition, can only tell you that 3 and 4 are right angles. That's all you can get. You can't get that they are equal unless you use this theorem, because that gives the equal sign in. You understand what I'm saying? Okay, so we mark those. And you could mark them with boxes since they are perpendicular, or you could just mark them with this. It doesn't matter. Either way is fine. Since they are perpendicular, this one gives a little more information. But all I'm really interested in is that they are the same size. That's what I'm trying to shoot for, right? So we got this by observing. See it said. We got this because an angle was cut in half, so the remaining angles, the two halves are equal. Definition of angle bisector. And we got this because we had two lines which were perpendicular, which means the angles formed there are equal by this theorem, not by the definition of perpendicular. 1, 2, 3. What's the pattern?
Angle side angle.
Angle, side angle. And the pattern comes from the picture, not from the order that you got these in. Okay? But you got to get 3, so you should be counting them over here. 1, 2, 3. Okay? What are they up? If I marked them, and you should, but you mark them over there. What's the pattern? Oh, it's angle, side angle. Yep. Think you can handle it? Too bad. Got to try it, Reagan. These are the assignments on each of these sections, and please don't be too daunted by them. I'm going to give you some time to work on them in class a little bit. If you use that time, it shouldn't be too much homework. If you don't use that time, you're going to be dead this weekend. Okay, so section 5.3, which is only about side angle side, that's kind of nice. It restricts what you got to shoot for. Here's the assignment. Ready? 5.3, and by the way, these are all 3 different assignments. I gave you a lecture on all of them on one day, but they're 3 different assignments. So 5.3 is number 2, 3 through 9 odd, 10 through 20, and 23. Number 29, if you can do it, no, I'm not going to do that one. That extra credit way too easy. No, maybe not. No, it's not hard. 29 is extra credit if you can show all your work. You got to show all your work and how it leads to the answer. Okay? Section 5.5. By the way, that was 17 questions on that one. Section 5.5 is 18 questions, and here's that assignment. Are you ready? 1 through 10, 13 to 15, 17, 19, 23, 25, 31. And on this section, 22 is extra credit. If you can do it, you got to show all your work though. And section 5.6. This one is 15 questions. So altogether, it's like 48 questions. 5.6 is 2 through 9, 11, 17 to 20, 24, 26. No extra credit on this one. 15 questions on that one. So you can have the rest of the day today, which isn't much, and all day tomorrow. If you work well tomorrow, and I'm convinced that you're actually getting something done, then you may also have Thursday. If not, we're moving on Thursday. So don't waste your time tomorrow, okay?